The objective of this activity is to find the area of a parallelogram. Let's understand the concept of a parallelogram and how to find its area. A parallelogram is a kind of quadrilateral. That means a four-sided figure. The unique property of a parallelogram is that the opposite sides, that means each pair of opposite sides, are equal and parallel. So if you name this parallelogram as A, B, C, D, the side AB will be equal to the opposite side DC, and AB will also be parallel to DC. Likewise, the other pair AD will be equal to the opposite side BC, and AD will also be parallel to BC, and therefore it is known as a parallelogram. To find the area of a parallelogram, we need to draw the altitude. If you select vertex A and draw a perpendicular on the opposite side CD like this and name this as AP. So what have we done? We have drawn AP perpendicular to DC. So the area of the parallelogram can be calculated by using the formula base times altitude. So what is the base in the figure? The base in this case is the side DC on which you have drawn the altitude. So the length of DC multiplied by the length of the altitude AP will give you the area of this parallelogram. This is the concept of a parallelogram and its area. Now let's understand what material is required to perform this activity. Squared grid papers, geometry box obviously for the drawing purpose, a pair of scissors for cutting work, Fevicol, and colors. Let's perform this activity of a parallelogram now.
To perform this activity of finding the area of a parallelogram, we have taken a squared grid paper and we have drawn a parallelogram A, B, C, D on it. You can take any dimensions of the parallelogram. It will work for all types of parallelograms. After that, using this vertex D, we have dropped a perpendicular on the side AB, and the foot of the perpendicular we have labeled it as E. So this is the height of the parallelogram. Now what we have to do is we have to cut this parallelogram into two parts. One is DCBE, this quadrilateral, and then we have this triangle AED. So for simplicity's sake, I have already cut it out for you so that we can save time. Here it is. This is the lengthier or the longer part. This is the one. See, it is exactly overlapping with the larger part there. And here is the triangular part. If I keep it here, it will exactly align itself, and you know that we have cut that original parallelogram. Its two pieces are separated out. Now watch what happens when I remove this triangle from here and I place it adjacent to the side BC like this. The figure which was originally a parallelogram has now been converted into a rectangle, and you all know that the area of the rectangle, this particular rectangle, is equal to the area of the parallelogram because the rectangle is formed from the parallelogram itself. So the area is length into breadth. What is the length of this rectangle? It is DC. And what is the breadth? Look at this breadth. This breadth is actually equal to the height of the parallelogram. And if you consider